Thank you for joining us and welcome to our physics experiment. In this video, I would like us to demonstrate how to verify Ohm's law. Of course, in Ohm's law experiment, we are expected to demonstrate how to verify how the current is moving across the circuit. This is a simple circuit for Ohm's law. If you look at this circuit, you can see the tip here, the longer tips here shows you the positive terminal, and the smaller tip shows you the negative terminal that is moving across the circuit up to where we connect the ammeter. A here represents ammeter, meaning that the current will flow from the negative terminal up down the circuit. When you come down, you will see here we have the resistor. This represents the resistors that we are going to connect in the circuit. And between the resistor, across this resistor, we have the voltmeter. So the voltmeter is connected parallel to the resistor that we have because it is connected across the resistor. That means that it is parallel to the circuit, while the ammeter is connected in series. So this is how the setup will be. So what are the requirements for us to do this? One, you need to have your ammeter. So here we have the ammeter that is required for us to do this experiment. Then we need a voltmeter. So here we have our voltmeter, and then we need the wires, the connecting wires, and we need also the resistor, and we need the battery, which is the source of power that will now guide us to see if whatever we are doing is in good shape. So finally, we have our resistor here. So those are the requirements that we need for us to verify the Ohm's law. So let me show you how to connect the above apparatus. Before we start our connections, it is good to note that the reason why we are setting all of this up is to note how the change in voltage across the resistor, how the change in voltage across the resistor will affect the current that will flows around the circuit. How the change in this voltage, because here we are connecting our voltmeter. So how does that change how will it affect the current? Because we see here there is an ammeter, meaning there is current flowing here. So how will the change in voltage affect the current that is flowing around the circuit? So during your connections, you must be careful to know which one is the positive terminal and which is the negative terminal. According to our circuit, we are going to start with the negative terminal. So we take our wire and we go to our power source. When you look at the power source, this is our negative terminal and this is our positive terminal. So we are going to connect our negative terminal, and then we go now towards the ammeter, and then we connect it also in the negative terminal. Then we are going to connect the positive terminal back to the switch. One end of the switch, we connect it towards the switch, and then we connect now the other end of the switch. We connect the other end of the switch back to the positive terminal of the battery. Now we are almost done with our connections. So we now take our voltmeter. Our voltmeter, as it is indicated here, is connected across the resistor. That means that it is connected in parallel. So we start with the negative terminal of the voltmeter. We connect that negative terminal of the voltmeter up to the negative. We are going to connect this negative side up to the negative end of our switch, because we know that we started with the negative in the cell battery, so this side will be our negative side, which represent the cathode. So you can connect that way. Now we are remaining with one connection, and you must pay attention here. The voltmeter range and the ammeter range is usually not the same. Because of that deviation, we are going to connect the positive end, we extend to 5 instead of 3. If you connect yours from 3, you will see that your voltmeter, when the switch is open, will deviate downward instead of going upward. So we are going to start with 5, which represents 0.5 up to the positive end of the switch. And when you do that, you can see now that your voltmeter is already moving when the switch is open. Now, when the switch is closed, let's see what happened. If we close the switch, the voltmeter goes down. If you close the switch, you will see now that the voltmeter goes down while the ammeter goes up. And if we open the switch, the ammeter goes down while the voltmeter goes up. And in the next video, I will now be telling you how you can now take the readings in both voltmeter and the ammeter. But this is the simple connection that helps us to verify Ohm's law, which is indicating how the change in voltage across the resistor affect the current that is flowing around the circuit. I remain your friend, Galagash.